Hi, I'm Barbara Bernstein from BetterTeachingNow.com, and in this video we're going to talk about simple equations with just one unknown and how we solve them. So first we have to understand what an equation is and what an unknown is. Let's say we had the following problem. I'm keeping this very, very simple, and you can answer it probably in your mind, but we're going to look and see what the principles are so we can apply those principles to more difficult problems that you can't answer in your mind. So let's say that I said, I've got some candy, and the number of pieces of candy I have, if you took away 2, I'd have 4 left. How many pieces of candy do I have? I've got some pieces of candy. I'm going to call them C pieces of candy. If I took 2 away, I would have 4 left. So a lot of times, though not always, equations have some real life meaning, or they're a way of saying something about something practical. But also mathematics is kind of a theoretical field, and sometimes they're just letters and numbers that are kind of like concepts or abstractions, and they're not necessarily representing something in real life. You can do math either way. Okay, so in this case, if we don't know what C is, but I know that if I took 2 away from C, I get 4, you can probably figure out that C has to be 6, because 6 take away 2 is 4. An equation is a statement that what's on one side of the equal sign is equal to what's on the other side of an equal sign. And you could think of it the way you think of a balance scale. If you've ever seen, or even a teeter-totter, if you've ever seen a teeter-totter, kind of similar to a balance scale, you've got something like this. And then you've got a plate on a balance scale that you can put things on either side. And you've got a seat, essentially, on a teeter-totter. Now, theoretically, this point would be exactly in the middle. I'm not sure if it is by my drawing, but you get the idea. So if you have 2 things on a balance scale and they're the same weight, the scale will kind of be equal and this line will be horizontal. Or if you put 2 people that weigh the exact same weight on a teeter-totter, neither one of them will go down to the ground. But if one side is heavier, it will tilt down, possibly all the way to the ground, depending on the difference in the weights. That's kind of what an equation is telling you. It's telling you that the things on either side are equal to each other in value. They may be expressed in different symbols, but their value is the same. Kind of like $1 is the same value as 4 quarters or 10 dimes. They look different. If you have $1 in one hand and you've got 10 dimes in the other, they don't look identical, but their value is the same. And that's what we really mean by an equation. It means that what is on this side is the same value as what's on the other side of the equal sign. And you notice the word equation kind of almost has the word equal in it. Okay, now what we're going to do is we're going to talk about a way to solve an equation, to figure out what the variable is equal to, that might seem very simple and obvious when the numbers are easy, but they're going to help us out when the numbers are harder and complicated. We'll be able to still solve because we'll know the principles and how we can manipulate the numbers and the equation. Now, what's a variable? So a variable, the word variable kind of comes from the word vary. And when you say, well, I like to vary what I eat for dinner, that means I don't want the same thing every night. So it means different things. A variable is something that can change in value. So this is called a variable because until I've solved the equation, it could be any value. I don't know what it is yet. In this particular problem, there's actually only one number it can be. But I call it a variable because I could use C as an unknown in any different equation, and from one problem to another, it might represent some different number. So it varies until I solve the problem, and then I find out what it's equal to in that problem. So that's what we're talking about when we refer to a variable. All right, now, if you've got two things that are equal, like, you know, on a balance scale, they balance to the same amount, what happens if you add 3 to one side? Are they equal anymore? No. The one that you added 3 to is now much bigger, 3 bigger, than the other side. But if I add 3 to the other side, they'll still be equal. Okay, here I have two things that were equal, an equation. What happens if I divide one side in half? Whoop, I get something much smaller, as long as I'm talking about whole numbers, that is. And on the other side, if I want to, it's no longer equal to what's on this side. But if I take the other side and divide it in half, so that I got half of the original amount, then again, they're going to be equal. So when I have an equation, if I take the whole quantity on one side and I add or subtract something to it, as long as I take the quantity on the other side and add or subtract the same thing, the equation will remain equal. And likewise, if I take one side and I multiply or divide that quantity on one side by some number, if I multiply or divide the other side by the same number, the equation will stay equal. I'll have two expressions that will still be equal in value. So here, what I want to do is I want to say C equals some number. What math teachers often say is they talk about, I want to isolate the variable on one side. Isolate means if a person is isolated, they're all by themselves. If a variable is isolated, it's on one side of the equation with nothing else there except the variable. So what I'm really going to try and do is get something that says C equals some number. So I need to isolate the variable C on one side of an equation so I can make such a statement. How can I get C by itself and not have the minus 2 on this side? Well, look at it. What I'm really saying is that C take away 2, here's C. If I took 2 away, I got to here, and that's equal to 4. So if I want to see what C is, I add the 2 back, but then I would have to add this back to maintain the equation being equal. So what you could think of this as is, here's one side of the equation. I'm going to add 2 to that, because 2 take away 2 is 0, and it's going to, anything plus 0 is itself, so I'm just going to be left with C on this side. But if I added 2 on this side of the equation, I've got to add 2 on the other side of the equation. So C is equal to 4 plus 2, which is 6. Sometimes teachers encourage students to write this horizontally. See, I added 2 on each side. Sometimes teachers encourage students to write it kind of vertically. And I'll show you what that looks like. C minus 2 equals 4. Add 2 to both sides. In fact, I could even say 2 equals 2. So I could really even express this as another equation. And so I take all this and add it together. C minus 2 plus 2 is C plus 0, which is C. 4 plus 2 is 6. These are just equivalent ways of laying out the writing that we're doing in solving the problem. So either one is perfectly fine. They're exactly equivalent in what they mean. I added 2 underneath both sides of the equation here. I added 2 on either side of the two sides of the equation over here. I got the same answer. It's just a different layout for showing your work. They're equivalent. So if you're in a class, I always recommend trying to take the approach the teacher has shown you, because then, for one thing, if there's equivalent approaches, she'll be able to check your work more easily. And you'll be able to get used to thinking of it that way and following what she does in class more easily. But a lot of times, there's multiple ways to do things. And truthfully, if you're doing something in a manner that's correct, that's what counts, that you understand what you're doing and you're doing the operations correctly. Okay, let's look at another problem. So in this case, my variable is x. And I know that if I take x, I'm picturing like a number scale going from the bottom. Have you ever had your parents or seen other kids' parents make them stand up against something that has a yardstick essentially with heights so they can mark off how tall someone is at the edge of a wall or in a door jamb, something like that? I'm picturing something that goes from 1 to 2 to 3 all the way up. So whatever x is, if I add 6 to it, it's equal to 8. So you can probably look at that and say x had to be 2. But now let's see how we solve it. If I want to isolate x, so I can say x equals some number, I have to get rid of the 6 from this side. I have to get x all by itself on the left side. And how am I going to get rid of 6? I can't divide it by something because 6 divided by 6 is 1. That won't help me get rid of it. But if I subtract 6 from this side of the equation, then I would subtract 6 from the other side of the equation, and x plus 6 minus 6 is x. 8 minus 6 is 2. And I want to point out that I could actually, instead of thinking it as subtracting 6, what's another way of saying subtract 6? I could call it adding what? Adding a negative 6, because subtracting positive 6, subtracting a 6, and adding a negative 6 mean the exact same thing. So look how that would be written. I would say x plus 6 is equal to 8. Now I would say add negative 6 to this side, add negative 6 to this side. X plus 6 plus negative 6 is 0. X plus 0 is x. 8 plus negative 6 is 8 is positive because there was no sign, and everything is assumed to be positive unless there's a sign stating otherwise. So the difference between 8 and 6 is 2, and I use the sign of the larger number.